What I wanted to do today is get some of the pull requests and issues that have been open for like a while. This one was opened on August 13th, so like 10 months ago. I want to get these merged because I should have done them like months ago. So that's what we're going to be working on today, and then we'll do some other stuff. But I don't really know what that other stuff is. I was thinking of playing with the new lightweight render pipeline VR setup. There's a new template for VR, and I don't know what that actually implies, but we might poke at that. But so, if you don't know, the Unity Visualizations project is sort of a open source project where I've kind of dropped a lot of the shaders and stuff we've developed over time. And so this is sort of just a collection of all sorts of things. And it seemed like a better idea to put all of the shaders and other things into just a single place rather than spread them all out. So they're all here, and you can grab specific ones if you want, or grab the entire thing and then work with it that way. But we have these pull requests here, and they're doing actually some really cool things. Some of them are just fixes. So I believe this one is just a fix, which is changing how we're doing some of this. And then the other one is actually updating our game of life script, which instead of doing the way we were doing it previously was to actually create a new texture every single frame, which is really slow. This introduces double buffering. And so what double buffering is effectively, think of it like two hands. And so those two hands are two textures. And so one texture, that like this one, is shown and actually drawn. And then the other texture is sort of behind the scenes, and you can't see it. And so you write to the one behind the scenes, and then you flip them, and then this one is shown, and this one gets new data written to it. And then you just keep swapping back and forth, and then you only need two textures, and you can just keep doing that over and over and over and over and again. And so that's how that works. And I should share the link to this stream because nobody else is going to know what's going on. So I will do that quick, and then we will clone this into this new project I have, and then get started. Some development. All right. So there's that, and I'll call it out in Discord too, just because. Doing some open source stuff. All right, cool. So the next thing to do is to actually clone this. And so the easiest way that I'm thinking, I've never actually tried this. Usually I'm just uploading things into this project, not the other way around, not pulling them back down. So we should be able to just copy this link, go into our assets, show and explore. So this is just going to bring up an explore window. And if you didn't know, there's this cool little thing you can do. If you want to open, say, a command prompt, you just type cmd, and it opens it up at the directory. And this also works for PowerShell. So you can just type PowerShell, and you get a PowerShell window. And so that's an easy way to do that. And then if we want to open up this in Visual Studio Code, for example, we can just, that's not right, do code -r and a period for the current directory. And so this will open our visual effects Unity project. Just open up that directory. And so we can expand the assets, and let's get a terminal and turn on screencast mode so it's a little bit easier to see what's going on. And so we want to go into the assets, because otherwise this isn't going to work very well. And then we want to git clone that. And so this should create a new Unity visualizations thing. And so that will have all of our scripts. And so we should be able to work with this as a way to test some of these new PRs. And there's also, I should point that out, there's also an issue that I also want to cover in this. So if we go to issues, find a position error of mesh, I think this is for the grass point render. Yeah, so this is recommending a fix for the grass render. So we'll take a look at that at the end, but yeah. So we have this. Let's see if that actually compiled. I haven't tried this with Unity 2019, so we'll see. It might do some updating, and we may or may not push those back out. There's some advantages and disadvantages to that, I guess. If it automatically migrates things, we might adopt some Unity 2019 features that would break it in older versions like Unity 2018. And I'm not sure if I want to do that. Blender could not be found. What? Blend file. Oh, okay. Aging controller. That's normal. So I'm gonna just remove that for now. This aging controller uses Morph 3D, and I don't have that in here, so it's not going to know what's going on. So we can kind of either take this out or delete this script just for now. I'm not going to actually remove it from the project, but that script is actually doing some dynamic weight changes for scripts, so it'll make things look like they're getting older. But if we don't have that project, it's just not going to work. Shield attack, poly to try. So this is our shield is breaking. What? Do I need that? I don't think I needed that. What was that for? Where did that come from? Okay, some random namespace was there. I don't know what that was from, but it's gone now. And then it can't load this because Blender isn't a thing. So, which one's having the issue? It doesn't say. But there's some sort of blend file in here. Or not. I would assume it would be in the grass, but I don't see one. So we'll just no idea. I don't have any idea where that's coming from. But it's breaking things. Is it actually breaking things? No. Okay, good. So that should be all of these projects pulled in, and so we should be able to actually just like make these work. I guess there's only one way to really test that. Let's see, contour map, that would do the build height shader. The game of life would do fun game of life things. Is this actually configured correctly still? No. So we can drag this over and assign that to the compute shader. It also needs a material, which we haven't assigned, but that's fine. And then an input texture. Okay, so that's going to do that. I'm not super familiar with all of these still, but let's create a new empty thing and just kind of run through these and just make sure some of them work. I'm not going to do all of them because that'd be a lot. But just to sort of make sure that things are still working. I don't really have tests for this, so we're just going to do it the manual way and throw like a material on here. We'll just do Conway's game of life. Sure. And we want to assign that to our script there and then attach that to our plane like so. And we can also assign this material to the plane as well. And so if I remember, this is probably not the best one to choose because it's using compute shaders and those can be a bit finicky, but we need an input. So let's throw in our game of life input, which has a whole bunch of random like test game data for game of life. And so it should create some gliders and a few other cool effects. And we'll see how that turns out. So if I run this, we should see it simulated. Yeah, cool. So there is our game of life being simulated by shaders, and that's sort of, I guess, a demo of how you might pull one of these visual assets into your project. You can see somewhere there's a glider generator, or two gliders, I guess. We don't have a generator, but that's that. Cool. All right. Next thing, we actually want to look at what the issues are. So we have these pull requests. Let's take a look at this one first, because this is open last. And it's been open for a while. I think I had requested a change, but I had requested it like more than a month after they had made the initial one. So what's going to happen is I think I'm going to end up merging this and then make that extra change, because this doesn't compile. This change doesn't compile off the bat. But I still want to get it in because it's actually improving things. And then we can move on from there. And so what this is doing is actually using the setters, and not the property values. So set vertices, set colors, and set triangles. And what this does is avoid requiring us to do a toArray on each of these data objects, which should be pretty good for us. It should avoid a lot of those modifications of data. Hopefully things are good. It looks like we're dropping a few frames. That's not good. What's going on there? Yeah, that's not good. Let's see here. Can I fix this while we're doing things? I don't think so. Yeah. What is taking all of those? What's taking all of my CPU? Nothing. Well, that's odd. Okay. Huh. Because yeah, it looks like we're getting like no frames a second, which is bad. Why is it trying to do? Okay, whatever. You'll have to let me know if it's really bad or if it's just me thinking it's bad. Let's see here. Oops. How's that? Is it any better? Okay. We'll see if this set stays good or not. It's been a while since I've done a live stream, so we're gonna explore this and see what goes wrong and what doesn't, and then I'll fix it iteratively as we do more and more of these. Hopefully, my goal is to do at least like one or two of these, at least one or two a month, but hopefully at least one a week. Don't know how soon we'll get to that, but hopefully soon. And so let's work on this. So this is working on our block terrain chunk mesh generator, which is our voxel stuff. So we can delete this plane. And I think, what does this do? It generates a chunk. So given a game object with a chunk and a chunk mesh generator and a Perlin chunk generator with a random seed of some value. Is this going to automatically create a mesh? I think so. So if I run this, what happens? Nothing, because the width is 0. So let's set that to a width of 8. So this should generate an 8 by 8 by 8 voxel cube. If I did that right. Did I do it right? Oh, what's going on? Do I not remember how to use this? We get our mesh, our chunk mesh generator, our Perlin. Oh, we need something to render this mesh. Renderer. Mesh renderer. There we go. That will probably help a lot. And let's also, because we're working with this, I am going to add a new material, which will be our block material. And we're just going to use our block shader on that, which should color them, I believe, it gets random Perlin noise values from that. So we should be able to, hopefully, video in output. Oh. Ah. All right. Let's assign this material to our materials here. And then I'm going to run this. We should get a new mesh and should actually be able to see it. There we go. And it's just a cube, but that's fine. Looks like we do have some holes in it, which is also good. And it looks like I should, if I stop this, does that fix it? I'm gonna explore a few things live. This might be a bad idea, but we'll see what's happening. I'm hoping that fixes the upload issues. And it looks like it did. Okay. So note to self, cannot transcode into 1080p and 4K at the same time. So let's not do that. Yeah. Okay, it seems much healthier now. That's good. Good to know. Let's do with this. What was I doing? Let's go and grab here. And now I have to figure out how to pull this change because it's been a while. So, review change, blah, conversation. There is. So what I want is this. If I click copy, what does that give me? Git branches. Oh. Okay. I do not remember at all how to do this. So we are going to go git branches list. Git branch help. That's going to do that. Git branch. Not a Git repository. All right. Unity or visual effects. Or not. Oh, there we go. Unity visualizations. And then we have a whole bunch of changes. Wow. That's more than expected. Probably not good. What? Oh. Oh. It's just a bunch of metadata stuff getting generated. So that's less useful. It doesn't look like any of our actual scripts were changed at all, other than the ones that I deleted. So that's probably good. Cool. We haven't dropped any frames since I made that change. So that is fantastic. Let's do a git branch master. Master is the only branch because it's local and I haven't checked anything else out. Git. Git fetch. So that should pull some new stuff. If I do git why don't we just search for what we actually want to do? Git checkout pull request. That makes way more sense. Fetch origin. Okay, that makes sense. Git fetch origin. Git branch. We still only have one. Is that because it's in their repository and not? Well, let's see if Stack Overflow is useful. Git fetch origin pull ID number head branch name. Git fetch origin. So this is going to go to our origin. Origin is the remote server, in this case GitHub. And so we're going to go out there, fetch some stuff, and we want the pull request with an ID of this 5. And we want to pull the head of that pull request and give it a new branch name. So we want the head. The head is just the latest version of it. And then we want to call this voxel setters. That work? I think so. Yeah. Okay, so there's a references thing on GitHub, it looks like. And so that's where that's pulled from. And so if we do git branch now, we have 2. So git checkout voxel setters. And we can see we get a whole bunch of fun new things. I think it's behind some of these other shaders. So this one is behind these, so those shaders end up getting modified. What we actually care about is our grass terrain. No. Is it here? I don't see it listed there. Let's see here. Which file were they touching? They were touching our chunk mesh generator, which we should have over here. So did that actually pull these in? Do our list stuff. And then we have our setters here. So let's see. Set triangles that takes a single argument. So there is no version of this set triangles. It doesn't exist. And so you actually need to give it a submesh, in this case 0. And so giving it a 0 submesh should please make more videos. Absolutely. Things have been a little slow. I moved in August, and it's been longer than I wanted to get started back up. But hopefully we'll do more. I'm trying to. I used to do a video every weekday, and hopefully sometime we'll get back to that. But yeah. Also, hello back to Russia. All right. Set triangles, generated triangles, submesh 0. This should compile, hopefully. And so we get this, some warnings, but that's fine. And if I rerun this, we should get exactly the same thing. Is that the same thing? Yeah. Cool. So it looks the same, which is great. We just need that one little fix in order to make this work. But that should be good. So what we can do is go in here and then merge pull request. Continuous integration has not been set up. I don't know how to do that for Unity yet. That'd be really fun to explore though. So we are going to merge this, bring their changes in, and then I need to go and pull master and make that tiny little change to update to a submesh. So we'll do this, that, done. And that should be in master now. And so if we go back to our code, we should be able to go to block terrain, chunk mesh generator, and actually see the change. So set meshes, or set triangles, set vertices, set colors are all there. And so now we need to go into Git, Git checkout master. Please commit your changes before, no? Where is it? I always struggle with Git's UI. We'll discard those changes. So those are gone. And then we can switch back and then Git pull. And now we have all these changes on master. And just add the submesh. Let's Git branch. I keep doing that. That just tries to open a thing. What is the Git command to make a new branch? This is silly. Hold on. Git new branch. Great branch. Voxels add submesh. Cool. So now we're on this add submesh branch, and we can actually commit this chunk mesh generator. So you can see the only change we have is this. So if I add that change up here, so stage that change. When you stage changes in Git, what that's effectively saying is sort of like grabbing specific ones and saying, these are the ones I care about. All those other ones we can kind of ignore for now. If you want to commit everything, you can do like commit -a, I think, and that should send everything. But for now, I think that should be good. Let's just make sure everything is still good, that I didn't randomly screw anything up. It looks fine. So we should be good to actually commit this. So let's say add submesh ID to set triangles call. Cool. Commit. And so this isn't going to be merged in. We've created this on a separate branch, so there's no actual changes that have been made. So what we need to do is, after a bit, that would pop up. Oh, duh. We committed this to our local version. We need to actually push this. So Visual Studio Code has just this button down here. You can't see it, but it looks like a cloud upload icon. And so if you click that, it synchronizes and pushes it up to the cloud, or up to your remote server. And in this case, that should put it up on GitHub. So now we should actually see it. So we go here. You can see it already sees there's a new one. So let's compare and pull request. So there's that. There's our change. Cool. Great pull request. And then we can just merge this. I don't actually need to be going this whole roundabout way of creating a new branch and then merging it, but it's a little safer, I think. Instead of committing directly to master, this way there's sort of a history of the changes in the pull requests section, which makes it a little bit easier to kind of see why things were made and have some discussion if you're working in like a collaborative environment. In this case, it's not really needed. It's just sort of how I've learned to work. So we'll merge that. Cool. And so that's done. And now we can Git checkout master again and Git pull. Let's remove that. And now we have these changes. If we can see, the last change was made by me 2 minutes ago. So that's good. Everything seems to have worked. Yeah, Awesome. So that's one down. Let's do the next one. Here we go. There's that. I can also delete these branches. I missed that part. But it's better not to just leave these all sitting around because they kind of just clutter everything. Because every branch you create is going to be in this list. And if there's like 80 of them just hanging out, it's no fun for anybody, especially if it's just like a one-time change. I just delete them afterwards. So yeah, that's that. But one down, one more pull request, and one more issue that I want to close. And then we'll do something. I don't know. I didn't really have a have a plan other than to get these done. So we'll do these, and then I kind of want to explore some VR stuff. But yeah. So this introduces double buffering. It's a bit more of a change. So there's a lot more stuff going on here. So let's grab this. Get pull request. There we go. So this is PR6, and this is double buffering. Cool. Git checkout double buffering. Done. And so this was for Conway's Game of Life. So we already had that working, which is sort of the goal of demoing it initially. I don't know how good that looked. We were having some lag initially, but we don't need all of this, so that can go away. Let's create a new empty game component. Create a new plane. Effectively doing everything we did like the first part of this. I'm going to move the camera for this and rotate it down. That's kind of weird. There we go. We don't need that game object. Main camera can see it from the top down. And then where's the Game of Life? Here we go. Everything still seems to be compiling. Let's put our material on there. Assign the Game of Life script. And this should already have... Oh, right. We need 2 render textures. I think those are created in the version. But we'll just take our Game of Life thing. And I'm curious if I can just run this or not. So this is their change. It looks like it automatically creates those render textures. Cool. And so this is Conway's Game of Life running with double buffering. I should actually double check that that's what it's doing because I haven't yet. But this is what it looks like. We're getting like 100 frames a second while I'm streaming, so that's not too bad. I don't know what we were getting before, but we can actually check that. So if we go back here, git checkout master. Cool. We should see this change. There we go. And we can run this again. And we get about 100 frames a second. So about the same. I don't know if that's actually a realistic thing, but in Unity's editor, we're getting about the same results. So let's see what's going on here. So right now, this is our current version. This is not the PR. So this is what we built in the Game of Life video. And so we enable random write, create a new render texture, do each of those. And then the problem we have is in our update, we're doing this, which is generating a new render texture, which we don't really want. and so effectively all that's doing is being really mean to everything because it's just not needed. And we have to re-specify all of this. We can just flip-flop between the two. And so what ends up changing, if I go back to the double buffering one, we have all of this fun stuff. And that new render texture, the second one, has been moved up into this area. And so what's happening here is we have this ping and pawn. And so I would assume what's going to end up happening is this is either going to toggle between false and true. and select one of these two textures based on that. So we get this render text ping, render text pong, default width and height. Cool. And we blank out our first texture. Ping pong, set that to true. If ping pong, that's interesting. Testing if it's true. All of this looks normal, and then what it's doing is just inverting this. So if it's true, it will get into this line of code, and then what ends up happening is it sets it to false, which means the next time we'll go here, set this to true, and go back here, and then it's just going back and forth, changing where the texture goes. So set texture blah goes there, and effectively looks like the input becomes ping, and then the input becomes pong, and vice versa for the result. So if our input is ping, our output should be pong, and that seems to be happening. And then the main texture should be the result of that calculation, and that's what we're getting here. So our compute texture gets run right here with the dispatch, and then with the main texture for our material, we actually set that to be our render text pong, and so we actually get the result to be updated, and that looks good. Neat. Some commented code. That step stuff was mostly for debugging, so that's fine. Doesn't look like that exists anymore. So that can be pulled out. And other than that, yeah, it looks perfectly okay, I think. Yeah. Okay, well that was easy. So we can go back here, merge this, update Conway's Game of Life, merge, done. And then we can go back to Git, checkout master, Git pull. And now we have that as our updated fun stuff. So now we have double buffering in here. And I kind of covered that at the beginning, but it might be a little bit choppy because we were having some encoding issues. So I'll go through it again of what double buffering is. Because that's kind of like a key concept in a lot of graphics stuff, and it's one of the probably easiest ways to avoid like weird graphical effects. And so what double buffering is like if you picture two hands, one of those hands is going to be rendered and the other one isn't. And so the way this works is you have your rendered thing and your not rendered thing, and you write all of your updates to the thing that isn't rendered. And then when that's done, you flip them. And so you take the entirely new output and say, draw this now. And then the back one, you just start overwriting that. And so you always have one static thing that isn't being written to, effectively like a read-only thing, that is just being used to show data. And then that gets flopped back out, and you can actually overwrite all that data when it's no longer needed. And you just keep repeating that over and over again. And it avoids rendering or overwriting what's actually being rendered to the screen. Because if you do that, then you get all sorts of weird things. In this case, what actually this is accomplishing is avoiding us needing to constantly be recreating new textures. So that's cool. So thank you to both of the people that committed those. What were their names? The Natural Tanuki and Ball Evan. So cool. Those are both in. And then we just had this issue, which was find a position error of mesh vertices. I watched your tutorial video a lot. That is amazing. I found a transform position of mesh vertices in grass point renderer. This is not correct because we add world position to points from mesh, and Unity transform will do that to transform again. So you may see the transform of points is calculated twice. That line should be positions.add origin minus transform.position. And finally, your work helps so many developers keep doing it. Absolutely. Thanks. All right. So this is a report for a problem with our grass renderer. So let's go check that out. So the grass render is under the terrain stuff. We have this. And which script did they say it was in? Grass point renderer cloud. So what does this? Or grass point, yeah. Point cloud renderer, blah. And so we have positions. Where is it? Here we go. Positions that add origin. So we add the origin, which is equal to this. Oh, yeah, that makes total sense. And so what's happening here is we have this list of positions. So this is the list of where all of our grass instances should be rendered. And then I also spelled this wrong. But what ends up happening is we take an origin, and then we decide where to put all these things. The problem is we're using the transform.position for the origin. And because we're doing that, it means that we're actually multiplying our position twice, because we're setting this, and then we are moving that into a mesh down here, which also has the transform position. And so it's actually going to get doubled. Unless it's at the origin, effectively, if we move to, say, vector 1, like 1, 1, 1, what will end up happening is this origin will get set to 1, 1, 1, and then get some extra random values. And then we'll go and set the vertices there. And then those will be modified by the transform, which is 1, 1, 1. So effectively, that origin position is now at 2, 2, 2. And that's not what we want. And so I think what we can do is just take this out, right? Or can we? There's some weird stuff going on here. Why are we doing this? Origin, ray, origin. Oh, weird. Why did I do this? So we're reusing the origin value. That's not right. I mean, that it's not wrong, but it's not right. So we may, the fix for this may not be exactly what they had written, because it's a little bit, actually no, it's still wrong, but well, yeah, it's still wrong, but it's less, well, more wrong. Yeah, it's not good. So we're reusing this origin value, which means this is used to send the raycast down, and then we end up hitting something which gets set here. So our hit point gets put into that grass, and then we add some grass offset, which is used to kind of make the grass either embed deeper into the terrain or hover above it if you want that. And then the origin X and origin Z is subtracting this X and Z position. This still won't work because, well, there's a lot of caveats to the way this works, but it doesn't work great in this case, because we're still going to get a doubled Y here. And for whatever reason, we're just subtracting the transform position X and Z, which I believe is what they had recommended in the first place. We're just not doing it for the Y for some reason. So I think if we do this, transform position.y, that should fix this. It still breaks if you, like, this whole script breaks entirely if you start moving things. Like if you move the game object after this is run, it breaks completely. But that's sort of expected. So let's see here. We should be able to condense this more into what they're picturing, like this. Origin minus equals this transform dot position. Let's use this there. And let's also use a new branch. So git branch grass positions. That didn't work. I still don't remember how to create a new branch. It's been a while since I used Git. I no longer use it at work, so. Oh, duh. Git. I do remember things. That's good. Git checkout grass positions. Done. All right. And so now we're working with this. Because I added this subtraction thing, we should be able to just take all of that off. Add a semicolon there. And while we're here, var grass position. Let's rename this second use of origin to the grass position. Instead of reusing the same name, because that's silly and I don't want to do that, let's fix that. And so now we're going to use grass position in all cases. There we go. Cool. All right. What else? Does that still work? I should have probably tested this first. But that should be fine. Colors, there's just like random colors going on here, but that's also fine. Let's see what this does. So if I do a new 3D object, let's do a plane. Center that like so. And then we need our grass. So we can put that at 0, 0, 0. And then take our grass point cloud render. And this needs a mesh filter and a mesh renderer, I believe. It's been a long time since we've done anything with grass, so this may be point cloud render. Oh, these are two different things, right? Yeah. This one is drawing instanced versions of things, and the point cloud one is setting points of a mesh and then using a geometry shader to actually render everything. And so what's going to happen here is if we go to our game object, we don't need two of these. We can take off that grass render, assign the mesh filter there. Seed size, let's say 10 and 10, grass number 100, I guess. Mesh, there is none. That's fine. This assigns the mesh, or it should. And then for the material, I don't have any actual like grass stuff. So we're just going to use the default diffuse, which should get us a whole bunch. That's not going to work. Can't use the default diffuse. We need to actually use our shader because otherwise it doesn't make any sense. Grass geometry, sure. And then we can assign that. Cool. So we get this mess because it's actually just drawing a whole bunch of white things. White looks like those don't look like cubes or quads, but that's fine. Oh, because we don't render quads. We render other things. We render like a triangle thing. That's not helpful. Let's give it a texture just to make sure. I don't know if that helped at all, but sure, that looks fine. So we'll go back to our grass and assign this new geometry shader to that. And we should get 100 things of grass. Well, that wasn't very interesting. What happened? So this, in our update, if the last position is not equal to oh, it automatically updates. So if I lift this up, there we go. Why? Oh, because vector 0, 0, 0 is going to be the default because there is no null. So last position equals vector 3 dot something none. Well, that's not going to work. And I can't set this to null because it's, can I set that to null? I don't think that's a nullable type. Yeah. So that's a non-nullable type. So we need some clever way to make this never happen. And I think what we can do is do vector 3 new vector 3 of float dot max value. Well, that should never exist. So let's just assign all of these to nan, which is not a number. So Unity might hate this, but since we're the only ones using this, I think we're fine. And so that should mean we'll always generate this, even when we're at 0, 0, 0, or any other value, unless you manage to initialize your transform to 0, 0, 0. This should make it so we automatically get this. And there's our grass. Cool. I don't understand. Unity 2019 has this weird scale default where it defaults to 1.5 times scale. And I think it's this low resolution aspect ratios that causes it to do that, but it's weird. But anyway, there's our grass. It's got some random wind applied to it, it looks like. And it should mean that as we raise this and lower this, for whatever reason, you can't see that going up and down, but it's now at Y20. The grass doesn't move, which is good. And if I move this, some indices are out of bounds. We'll fix this as well. See, so I know I can set the vector 3 to nullable, but that feels like this will set it to nullable, and you mentioned that, but it also has some weird other implications because suddenly we have to do all these null checks everywhere. I mean, it's a private value, but it also means we should be doing like if last position dot has value every frame, like here, and then do an and or something. What am I doing? There we go. So we could do that, and that would cause it to get initialized as well. I don't know if that's better. That might be better. Yeah, I guess throwing nan into a vector is probably not the best idea, because if anybody ever tries to consume that, it's going to get awful. This is a little more explicit because it says it could be nullable, so it's telling people, hey, make sure you check that this is nullable. So I guess that Yeah, I kind of like that. All right, good suggestion. Last position equals no. Cool. All right, so we can save this. And everything seems to work until we get out of bounds. But I'm not going to fix that in this branch. We might want to fix that later. Because I think what's causing that is down here. Is that what's breaking it? Indices. Yeah. This is our problem, I'm pretty sure. Where we set this equal to the grass number, and then we say there's 100 indices. And then it tries to, well, that should iterate, that should set them to 0. What's throwing the error? Some indices are referencing out of, vertex count 99. Oh, is this? So what's happening is in here. Wait, why does it? Oh, that makes some sense. So what's happening, we're iterating over I for each blah in I. That doesn't work because if like the 50th vertex is out of bounds, we generate this and skip this, and I increases, but we only have one less total vertex. And so what can end up happening is we get to the end, and now we have 100 vertices because it's still incremented all the way to 100, but that many vertices were not created because we skipped over some in the middle. And so this I is actually greater than the number that could actually exist. So the fix for this is going to be something like, there's a lot of fixes we could do, but the most straightforward is probably to take the positions .length or something like that, .count. And that should work. Ideally, though, this would get refactored out and use like a list or something. And then everything is just referencing those lists, and we can remove the reference to this logic up here in this actual thing. So we're not actually referring to that. I'm going to keep that for now, and we can come back. I mod length. So if we start like modding it, what might end up happening, like that will get rid of the error, but we'll also then be drawing multiple vertices over. And I'd like to avoid that. So like if for whatever reason, like 50 vertices are out of bounds, we're not drawn, then I just want those 50 to not be drawn. But if we do a mod, it will just redraw everything twice, I believe. And that doesn't seem great. And technically it would actually create two unique instances because they'll have different colors and theoretically react differently, which is just could be weird. But I think we've solved the issue that the issue is talking about. Just to make sure, let's check out master again. And so this might break a few things. I'm sort of expecting the grass to disappear. But it hasn't. That's cool. All right. And so we do this, and now I should be able to go back to our scene and increase Y. And so this is sort of the problem that I was sort of alluding to. We'll actually raise our grass off of our terrain if Y is not 0. So that's what this issue is fixing. And if I actually set this to 1, I think what we'll find is that grass is on Y2. So if I just create a cube, or it's just Y1. Interesting. Okay, I was wrong. Either way, it's wrong. And we fixed it, so that's good. So let's jump back. So Git check out grass positions, done. Go here. Theoretically, this should recompile and work, right? Or not? Did it recompile at all? I don't think it did. Also, the mesh is getting preserved, which is interesting. Between plays, the mesh is not going away. But if we go back to our scene now and raise this back up, it's still broken. We need to recompile this somehow. There. I don't know why Unity didn't detect that, but it should now. All right, cool. It regenerates, and now I can still raise it, but that's because we're not running, so the update is not actually ticking. If I play this, we should be able to go to the scene, and everything should be fine or not. What? Now I'm confused. This was working, right? So why isn't it anymore? So we have our grass position, which subtracts the transform. Oh, but it's still going to accept that as our... No, because it regenerates it. So like these grass points should be at minus 2.61 when they're generated. And that's not happening. This is a mistake. Oh. Oh, that's what's happened. Okay. So what that tells me is our regeneration is not ever firing. So if it has value, if it doesn't have a value, or our logic was wrong. If the last position that has a value, that would never be true. So we would never regenerate a mesh. Now we check if it doesn't have a value. So if it is just initializing or needs to do this other stuff, then we should regenerate the mesh. And that should hopefully fix the Y centering issue. So we should be able to raise this, and we're increasing our Y position and nothing's actually happening. I can add that slot. There we go. So there's 7,000 grass instances, which is a few. But it seems to be doing all right. So that's pretty neat. That's cool that this still works. It's been like a month or a year and a half or so since we did this, and it still seems to be doing just fine. If we added grass to this, it would look like grass. So that's pretty neat. Yeah. So I think that should close out that issue and should resolve everything. We'll still get some X and Y issues, or no, never mind, we shouldn't. It shouldn't double the X and Y because we still are centering based off of the origin or the X and Y position, but we're actually using the origin to actually cast this. So this should be able to not be centered. What I'm saying is if I increase this, we have this size 10 thing, effectively a cube. Let's make this a little bit more dense just so it's easier to see. And then as we move this around, we should see the grass move still. And we can move it up and it does fine. What I was concerned about was we might move this and it would still be centered at 0, 0, which we don't want. So this is movable grass and it should adapt to terrains and things. So if we were to add, let's say, a sphere, let's make it a little bit bigger, like that, and move this Let's make it a lot bit bigger. Too big. Also maybe a bit too big, but that should be fine. And then if we move this, oh, I know what's happening. It's a sphere collider. So it looks very wrong because I didn't scale this exactly, but it's colliding with the sphere collider. So it's actually hitting the sides of the sphere there. So everything seems to be working just fine. And then we can move this and we get grass moving around a sphere. Cool. All right. And we can really crank this up to like 50,000, I think, and it should still run. Yeah. A little laggy to move it, but now it should look fine, and we get relatively normal like wind and stuff going across it. So that's neat. Cool. So everything's still working, and we can get this committed. So what's the thing we changed? I should add a git ignore for all these meta files because there's way too many. Grass point shader. This. So here's what we changed. Checks for null. And then uses a grass position and subtracts everything. Cool. Grass position. Grass, let's call this grass point cloud renderer location updates. And then we need some extra information here. So check for use nullable vector if vector is null, then regenerate grass. Vector is null by default until initialized. And then grass positions are calculated correctly for all transform values. Fixes issue number 8. I think this works, right? You can just link things like this. We're going to find out. So fixes number 8. And yeah. So that should be that. I think this works. We'll see. No stage commits. Cancel. We definitely do not want to commit everything. So we'll stage that grass. You can see the changes go away because we staged the change. And now we get the changes here. And those look good. Cool. Let's commit that. And push that. And we should. I'm curious if it gets referenced here on this issue. Because I think I did everything right to reference it. Added a commit that references this issue now. Awesome. So that's there. And then we can compare and pull request. Fixes number 8. Cool. Well, that's how you reference things in GitHub, I guess. That's neat. Let's merge this. Create pull request. Done. And then there's no continuous integration. We already went through that. Let's merge it and confirm. And then delete the branch. And now, did you get up? Yeah. Awesome. So when we close that, or when we merge that pull request, it also closes it. Reference pull request that will close this issue. Cool. So that's done. And now the only issues that should be open are mine. Awesome. So we're done. So those are our 3 changes, I guess, for our stuff. Why does it say there's only 2 contributors? There should be 3, right? Weird. Why aren't you? Odd. Okay. I'll figure that out later. But anyway, that is everything that I wanted to get done. And now we gotta play around because I don't have anything else to do. So I don't really know what that means, but we're gonna see what's going on. So I think that's, yeah. Is that everything? The only other thing I want to say is thanks to everybody that has contributed. Like people contribute all the time in comments and things or in the Discord. But it was really cool to see these, and I kind of dropped the ball on getting these merged. I'm hoping that I'll get better at this because this repo is definitely the most popular from the channel. So I probably shouldn't let it just sit for months, almost a year in some cases. So yeah, if it does, if you do try to like contribute something like this and it stays open, ping me, and I will make sure it gets closed. Either in some way, make sure that it gets addressed because that shouldn't happen. But yeah, I think we're good. The thing is, there are 2 projects that I'm sort of working on as sort of like a crazy transition. There are 2 projects that I'm sort of working on that I thought we could either explore. There's Asteroids VR, which we've done a lot on the channel. Kind of brought that back, and then tried to do some testing stuff and got really annoyed. I can show you what that looks like, but it's it was annoying, so I stopped. Testing in Unity is weird. And so the solution I found to test mono behaviors ends up configuring them to only compile in edit mode, which means they can't actually run in your game. And I don't know how to fix this. And so like we have all these tests and our stuff is under test, and that's great. But what ends up happening is if I go in here and try to like grab our health tracking component and put it on here, it is flagged as an editor script now because we're using it in our test. And that means that we can't actually use any of the components we put under test. And that clearly isn't what we want, but that's where this ended up. And so that's not great. So what I'm thinking is we can grab this, and one, I want to move over to the lightweight render pipeline. And we haven't really gone too far with this. So let's do a new project. New project name. And there's this VR lightweight render pipeline. It says it's in preview, which means it's probably a really bad idea for me to actually create a big project on it. But I kind of want to try it anyway. So we're going to see. So let's do a VR experiment. See what happens. And then, yeah, I at this point I have mixed feelings about this testing stuff, mostly because it doesn't seem like it's very well documented, and it's just has weird behavior. So yeah, I guess that's sort of where I've ended up. I don't know if we'll like roll something from scratch. That seems like a lot of work, or if we'll just manually test everything, which also seems like a lot of work. I was kind of hoping that this would be sort of like an easy way to plug and play testing, but I don't think it is anymore. Maybe it is, and I'm just using it wrong, or that's like not documented in the way that I want it to be documented, or whatever. But I haven't figured it out yet, so I'm gonna keep kind of plugging away at that. But for now, I think we're going to kind of ignore testing that kind of stuff in that way, and we'll add it as we need it. So this is creating more stuff. I've never actually tried in Unity. I think 2018, like the later versions of 2018, had this too. But in the Unity hub, they added templates, and that's what I'm using here. And effectively what those do is include a whole bunch of extra stuff that you can use to actually set up your project. So it's not just like this default empty assets folder and main camera and directional light like base scene. You get a bunch of extra stuff. And I imagine this one is going to come and like automatically start your VR stuff when you try to run this, which maybe that's good, maybe that's bad. Generally with VR stuff, I don't like running VR to test it, because VR is kind of clunky and hard to test. And like if you just have a headset sitting here, or you have to like put it on your desk, and I don't have space on my desk for a headset, mostly because it's full of other clutter. But right. So we have an XR, so I'm assuming that's mixed reality thing. Camera floor offset. Main camera left hand, right hand. So this is like the Steam VR stuff, but it's tracked pose driver. So what is the difference between this and VRTK? So VRTK is an open source VRTK. This, which I've used in the past. It's an open source cross-platform Unity thing, and I think Unreal as well. And gives you a few extra fun things, but it's a very event-driven, fun way to do VR. It looks like they're using their own thing, generic thing. Well, I guess there's one way to see what happens. We can run this and see what happens. If this launches Steam VR, things might explode because one, Steam isn't open right now, and two, Steam VR doesn't like me. Ooh, that doesn't look good. Well, all right, we're getting Steam VR, so I will be right back. We need to grab our controllers. All right, this can go over there, I think. I'll have a chair here. Come on. Sure. Okay, so just as a demo, it does work. There's our scene. Well, that's handy. So plug and play stuff seems to work. Does it show a controller? No. So there's no visualization of our controller. I don't know which hand this is, but I think we need to actually add a thing to this. All right. So let's add just a random game object to each of these, cube and a sphere. All right, so this one, this is my sphere, and the cube is somewhere else. I guess right there. But the other one is the other controller isn't on. So it seems if you have ever worked with like the Steam VR stuff, it seems like it's very close to that. And that worked, I guess. This seems like it'll do more. Two controllers, rotation and position, update type, update and before render. I don't know what that is. Use pose provider. I don't know what that is. Lots of things I don't know. All right, so we can move that down there. The cool thing is we get all these new lightweight render pipeline post effects. Historically, doing things in mixed reality or in VR, like post effects in VR, was kind of hit or miss. It sort of worked, but it didn't always work. This seems like it adds a few extra fun things. So we might be able to do some cool stuff with this. Let's see. Right now we're just kind of staring off into the sky, which is fine, I guess, but pose source head. Color camera center, right eye, left eye. Oh, interesting. So there's different tracking solutions. So I guess if we want to like overlay something over a specific like part of view, we might be able to use this. It seems like that would work. Camera stuff. Cool. Left hand, right hand. What else does this add? Do we get mixed reality? And the only other thing we get is this tracked pose driver. And I don't really know what that is. AR, we get a world anchor. We don't need that. What I'm trying to evaluate is if this will make sense. If it's worth it to kind of like dive into this for Asteroids VR or to use VRTK. So I don't really have a preference right now. Both should work. And I think, like if I stop this, can I create a scene that doesn't use this? So if I disable VR effectively by turning off that mixed reality thing, can I just make a default camera? Like if I turn Steam off, turn everything and just make it go away. I don't know what that's doing there. If we just add a default camera, this might be weird because we actually removed a lot of like the post effects and things as well. But if we run this, do I still get everything working just without VR? Or is it going to try to start Steam VR? It looks like it's starting VR. Yeah. And is this... Because that's not 0, 0. What the heck? Hold on. What's going on? Because 0, 0 should be in the ground. And this is not in the ground. We're like standing position. What's going on? If I move this, it's still initializing. Oh. Oh, well, that's unfortunate. So it doesn't look like there's a easy way, unless I have to turn something off. Because right now, we're just stuck with the display. Maybe that'll work. So if I turn this off again, we're just going to keep trying this. Because what I want to get to is to the ability to run this like a VR game without having to put a headset on to test it. I want to be able to develop something that sort of simulates VR. Or simulates at least like controlling the player and being able to do like basic actions like play the game without actually having to go into VR to do it, so that it's just a little bit faster and there's less clunkiness, I guess. So if I turn the target eye to none, that should go here, right, to the main screen. That's my assumption. I haven't actually looked up any of how this works. Just kind of poking at it. So we'll see. That lag is never a good sign. And it looks like it's starting it. Render stuff. physical camera. Well, that's unfortunate. Let's see here. Upgrade stuff, project settings. And it's still tracking. So interestingly, it didn't update our camera. So maybe I just need to delete that. And SteamVR is going to get angry at me because I keep restarting it. And it doesn't like when you do that. But here we go. Camera, cool. Start this. Maybe there's something going on in the post-processing volumes. Eh. Yeah, it's starting SteamVR again. Nope, nothing there. Directional light, good, nothing there. Example assets, I don't think there should be anything here to say this is a VR thing. Yeah, that doesn't make any sense. So we get our camera. And I would assume the setting has to be in here somewhere, but I don't see it. But in here, in the project settings, maybe something else is going on. Tutorial info settings, scripts layout, readme. Okay. Readme editor. Okay. Project settings, materials, example assets, anything up here? So there's just some documentation there about what this is actually doing. Can we turn VR off? Oh, we can't turn that off in play mode. But we should be able to come down here. Let's see, it's got Oculus support. And OpenVR. So OpenVR, I believe, is the same thing that SteamVR uses. I believe they both are using the same thing. What else can we add? Mock HMD? None. So if I bring that all the way up, I'm assuming what happens with this list is it goes down the list. So it will check, can I run none? Is none supported? And it will say no. And then we'll check, is Oculus supported? And it'll say no. And then it'll say, is OpenVR supported? And it'll say yes. And so if we put none at the top, I'm hoping we end up with this just working. And it looks like there's a mock HMD as well. Cool. Okay, so we can just do none. And none means we don't get a VR stuff. We don't get any VR stuff. So that's cool. Now, let's go and see what happens if we use a mock HMD. So this I'm assuming is like some sort of simulator that they have. And we'll launch something. Or just play. That's interesting. All right, there we'll get our mixed reality thing back. That might have, nope. All right, didn't undo the settings, just undid the scene stuff. So let's start this. And we use the mock HMD instead of that. Cool. How do we use that? Is there anything we can do to interact with that, or is that sort of like a placeholder thing? All right, let's go and see if we can grab some documentation on that. Go here, README, and we want the VR overview. Enabling VR support. So you can specify a device at launch using this. So that might be useful for actually like releasing your project, but we're not doing that. Load device by name. Not super interested in that. Automatic head tracking, understand the camera. Vive. There is a nothing about their mock HMD. At least not that I'm seeing. So I don't know if we'll ever use that. I think we can just get away with none. And so we want to remove this and just use none as our head-mounted display. So when we run this, we should still get everything working. We just sort of get like a default behavior. So I assume this is set to some normal realistic-ish default. 1.36, that makes some sense. That'd be like I'm failing my metric conversion, but that'd be like 4.5, 5 feet, something like that. A little less, but yeah, hopefully we can use this. This should work though, because I assume these mixed reality settings are also used for VRTK. So we may not actually need to use all of this. One thing to check though, when was the last time this was updated? I think version 3 was recently released. The one thing I check when I'm using open source stuff is just when it was updated last. Support tracker. Version 4 is the latest version and is currently in beta. All over the place. Let's see, VRTK GitHub. Yeah, so it's still being updated. I believe they got some sort of grant from Unreal, I want to say, for support. What I don't know is what state version 4 is in and what makes sense. Because one of the cool things that VRTK did was it kind of changed Unity's default way of working with things. So instead of using like constant update checks and things like that, it actually relied on an event-based system. So like, did you grip something, or did you interact with an object, or did you try to move, or any of those kind of things? And that made it kind of easy to support things. It was very different than Unity's like update loop. So I don't know if there's anything like that in the new Unity stuff. I don't see anything. Nothing that seems like that. The biggest thing here, it seems, is that it's supported by their input system. So you can actually map controls on your device to Unity's input system and use that. Which that actually sounds kind of cool. So for, I guess here's the mapping. What do these mean? Legacy input index. We don't care about that, I don't think. So it will support things like the trackpad. I'm curious how it will support things like the Vive index, which is new and I don't think it's not listed here. I would assume it's similar to the Vive, but I'm curious, like, for both of these, what would happen as new devices get introduced? How much work is required to keep your thing working on all of them? Let's see here. What else? All of those are just different input things, accessing input devices. XR to input devices to get the input devices such as controllers and trackers that are currently connected. So that would be a way to like discover new controllers. Accessing input devices by role. Hardware tracker. Oh, so like if you have like the Vive tracker pucks, this would give you a way to reference those, it looks like. It also looks like the lighthouses, for example, might be used as tracker or input devices, as like tracking references. So like the HTC Vive uses lighthouses, which are just infrared things that spew infrared light, and they get picked up by the device, and it figures out where they are relative to that. The Oculus uses actual cameras and locates you that way. Look, at least for the Oculus, it looks like that will be reported. Let's see. I should also point out, if you guys have questions or anything like that that you want to ask, leave a comment or let me know, because I'm just going to kind of poke at this and see where this ends up, and then yeah, we'll see. But if there's other things like other questions or whatever that come up, we can pivot and work on those as well. So kind of open, just kind of hanging out. So left-hand devices. So how is it detect? Oh, so a node can be flagged as left hand or right hand. What else does this have? Input device role. Well, I guess there's an easy way to check what it supports. Let's create a new script. Test. All right. New everything. All right. So we get this thing. Let's go and inspect you. Can I inspect you? It really didn't seem to like that. Unity engine .xr. XR does not exist. All right, so we get left eye, right eye, center eye. This might actually, so left eye and right eye, I believe, hello, I believe left eye and right eye is useful for like eye tracking. This is all like a random hypothesis based off of this. I'm curious. It doesn't look like these are flags or anything. So a game controller is different than a left hand. So as an example, this is a controller, but it is a left hand or a right hand and not a game controller. A game controller would be like this. Just like an actual game controller, I assume. And then tracking references would be like a puck. And a hardware tracker, well, that might be a puck too. One of those is a puck and one of them is not. So, let's see. That should be all of those. So that will give us a way to sort of like, if we want like to give your right hand like a bow and your left hand a sword, or vice versa, we can actually do that with this. VRTK gives you all that stuff as well. So this isn't anything new. This is just how this works in Unity's system. And personally, I'm leaning more towards using Unity stuff just because it's the first party solution. And I'm imagining that it seems to be taking a lot of draw from VRTK's thing. It's not to the same level, I guess, but it seems very similar. Let's see here. Input features, device to try get features usage. So this will return a list of all of the features supported by a device. Oh. To return into a generic... What? Input feature usage. So is this something that we define? Or are we supposed to go and test? I don't know how that would work. Try get feature value, trigger button. Oh, okay. So what this whole get feature thing is doing is saying, let's say we want to see if a button is pressed. You would use try get feature value if you are not using the input mapping that they have. And this would let you test one, if that exists, and then convert that into the value that you give it. So in this case, they're doing a Boolean. So they give it a Boolean trigger value. Do this try get feature value, and then get a value back out saying, is the trigger button either true or false? And if it is, then they go and say it's pressed right there. So do I use amplify shader? No. I think I have that asset. I've played with it a little bit, if I remember. But for the most part, I either write my own shaders or use shader graph. I haven't really been doing a lot of shader stuff lately, though. So no, I don't. It seems useful though. Like, it was one of those things that was really cool, and then I ended up just learning shaders and then not going there. But there's certain things, like when you're writing your own shader, that are really just not intuitive or straightforward, or you need to already know sort of what you're doing. And those visual things make it way easier, like substantially easier. Even shader graph, for example, gives you a pretty easy way to do things. Like if I go in here, let's see, shader, PBR graph. So if I create this is a bad example because it's in the wrong place. But if we edit this, there is a Fresnel effect, for example, which does this outline sort of thing. So if you're thinking like atmospheres or things like that, if we just plug this in like that. Oh, that's into the position. Let's do that into the albedo. Oh, that's into the position. That didn't used to exist. So that's cool. That means we can actually change do vertex shaders. Cool. Okay, I didn't know that existed. Let's just plug this into the albedo. And so what you end up getting, like I'm rotating the sphere here. You get sort of an outline or an atmosphere effect, or like we use this in our shield shader, for example. This is, you can do this, but the math can be a bit intimidating and weird. So it's pretty cool to be able to do this in like shader graph, for example, or it works in Amplify too, if I remember. But yeah, that is pretty fun. I'm going to delete that though because we don't need that. Don't save. There we go. All right. Primary button watcher. For all the devices with the primary button. Okay, that's cool. So this is going to iterate over and try to find if any of them are using the primary button to do anything. Okay. That seems handy. And then this one is going to depend on that and just react to it. Add listener. Primary button watcher. What is add listener doing? Is that a default Unity thing? That's not added to the, oh, primary button press, add listener. Oh, so they're defining a new event. Okay. And then they're using Unity's event system. So the primary button event, I assume, is something new they define? Yeah, up here. And so that's just a basic Unity event that sends a Boolean of it's pressed or it's not pressed. And then when it gets detected down here, when the state changes, they send a update to that event that tells them the state updated. Makes sense. And then this second script is watching that and doing some extra stuff. Looks like setting up some sort of coroutine to rotate it. Yeah. It's just doing a rotation of the animation. It's animating the rotation. So given a start and an end, it creates a animation over time using a coroutine to slowly rotate to that new point. That's actually kind of cool. Using a coroutine for that. We may want to dive into that in some future video because that could be really cool. And I've never done anything like that, so that'd be cool. And then it supports haptics, so that will be like rumble. I imagine that's supported. I imagine out of by default that they don't support things like the vests and things that you would wear. But that's probably fine because it'd be cool, I guess. But I don't really want to add support for that out of the gate for like Asteroids VR. That doesn't really make any sense. Just because one, we don't even have a game yet, so there's no point in adding all this extra cool stuff when you can't even play it in the first place. Input for OpenVR controllers. So here's Steam's thing, Valve, the mapping, menu button, blah, Oculus Touch. The table below lists controller inputs for each OpenVR supported controller, their interaction types, Unity access, and button IDs. Unity button ID. Is that in the input? Is this actually? Oh, it's already set up. Cool. That's not set up for what we want. That isn't either. Left index 0. Access. Okay. And so this, like Oculus Gear VR D-pad X, maps to the 5th axis of the joystick. So if we look here, the 5th axis is not, there it is. The right trackpad controller, or the right controller trackpad. is the 5th axis. Okay, so that makes some sense. So effectively, we just need to reference these tables and set up all of our inputs that way. We might want to do some fancier thing if we use this to do that. I don't think VRTK, to my knowledge, they have their own input system, and it's all, like I said, it's sort of event based, and so there isn't this reference to Unity's input system. That's just not used. But using this might not be bad. It can be a little bit clunky at times, I guess, but that might be all right. It would definitely help for actually testing this, because what we can do with all of this is if everything maps into Unity's input system, we can actually add support for other things. And so like we have all this Oculus Gear VR stuff, but we also have all of these other things. And so as long as we named them the same, what would end up happening is we would get like universal controls. So I could map it to a gamepad, for example. And so you could actually just fly around with a gamepad instead of actually having to put on a headset. And that seems like it could be really useful. I don't know if there's any downside to that other than we're using Unity's input system and it can be a little bit obscure. Like this is going to be trying to figure out all of these axes to map everything to. And that could be not the greatest experience, I imagine, because like effectively we have to come back to this table and make sure everything is set up as we want it. And I imagine as more devices get added with different input systems, this will go beyond 27 and we'll end up with more and more and more. And maybe they'll come up with some way to condense all of this or make it a little bit easier. But my concern might be that it would grow and potentially grow a lot, depending on what happens. So that could turn into a problem. I should also mention right now, like the target for Asteroids VR is a Vive, because I have a Vive, and it'll probably be an index as well, a Valve index, because hopefully we'll get one of those. Oculus will come next, and the plan is for those 3 devices to work really well. I just need to actually like use all 3 of those because I haven't, and so that could be a problem. But for the most part, like I'm testing and targeting a Vive, like original gen Vive with the Vive wands, and then everything else hopefully can kind of build on that platform, which is part of the reason why I want to build this, so that you can play it with just a controller without any VR stuff. Because if that works, theoretically the rest of the stuff should work as well. Because then it's just mapping different inputs to the different systems, and it's not anything specifically built for those headsets. So there's not any like one-off things for that, and that hopefully will avoid some of those issues. That's pretty much all we need for the input stuff. Audio spatializers? Natively supports audio spatializers? Okay. I don't really care about that at the moment. This is a way to sort of inject like 3D sounds into normal things. Like Windows has this by default in your audio settings. There's a way to actually inject 3D sound into your normal like 2D headphones. But we can worry about that later. Single pass stereo rendering, VR devices, that's fine. Yeah, I think for the most part, I feel like this, like we don't need a lot of like crazy extra stuff. for what we're doing with Asteroids VR. The way this whole system works is, well, I can actually, hold on. So the way that Asteroids VR Navigation works, I posted out like a private video of this like a year ago or so, but it's all based off of like relative rotation of controllers, which means it doesn't actually matter at all what we're doing for any of this other stuff other than that we have access to these two tracking points. We need the left and the right hand. And then effectively what it does is it draws a line between the two controllers, and then another one effectively creates a vector in the center that is up and then horizontal and then forward. And then as you rotate these, for example, like if I did this, that translates into a roll. So your entire character rolls forward. And then you can pull it back and you'll tilt backwards or do this, and you'll spin to the side or do this, and you'll kind of turn around. And so that's how the input system works. And so all of that is based off of the position of these relative to where you are, and then also the rotation of them. And so just rotating them is going to be the rotation value, the quaternion there. It's not going to be any input or anything coming from this. And so I don't think we need anything like super advanced there. There's not anything crazy going on. We're really just using the inputs from these controllers. The only thing we need is to actually detect a button press. I was using the grips for that. And so if you're holding the grips, that becomes active. And so like if you just start doing this, you don't start like wobbling back and forth, because I don't really want that. And the game already induces a lot of motion sickness just because there's 6 degrees of freedom in VR, and you can't actually physically spin in 360 degrees in every direction. That just doesn't work. And so this is sort of a way to get that to work. And so I think this should be fine. And we've done this implementation like 3 different times now. And the first time was with Steam's plugin, and that wasn't really supported. And so then we came back and did VRTK, and that's just like 2 versions later now. And I found it kind of clunky, or not really clunky, but doing the event-based system, there was a lot of connections that you had to make. And for what I'm trying to do, that isn't super useful. Because a lot of the stuff is like custom interactions and things that aren't done in a lot of things. Like a lot of it's just like, how do we rotate the player? And then how do we track things? And so I don't need a lot of like can I grab onto a wall or open a door or things like that? That's not really part of it. There were some nice things, like a really nice physics plugin so you couldn't like walk through walls. But we built that in Steam VR relatively easily. So I'm not sure there's a lot of benefit to taking on a VRTK dependency when we can just do normal Unity VR stuff. I think that makes sense. The only downside is this is the preview, and I don't know what the actual like end support is going to look like. And so it could be like dropped or changed dramatically or something like that. And if it does that out from under us, then we're kind of stuck until we fix it, which isn't really a good place to put ourselves in. But it also, like, that can happen to anything. Because really what I'm looking at is VRTK 4, because that's the newest version. It's in beta, but again, we're sort of starting off development, so we might as well start with the new stuff and then build to that and then update as time goes on. Or this beta. And so we're kind of stuck between a beta and a beta, which means that it doesn't actually matter one way or another if we're worried about a beta. And I imagine both of them will come out at some time, because VR isn't going away, I don't think. At least I hope VR isn't going away, because I'm spending all this time making this thing. So Yeah. I think we'll go this route. And this way we get the lightweight render pipeline, which is handy because it means we get all this fun new stuff. We should get all those volumes, and yeah. So let's see here. Does this? Yeah, we can still do the is global stuff. Can we? Yeah. So if I add a collider, box collider, and then turn this on and off. Cool. So I did this thing on post-processing, a video on post-processing volumes earlier last week, I guess last week. And sort of as a way to kind of demo this, it's sort of a handy way to mix post-processing effects. In this case, when you go in that box, it applies extra post-processing effects. We can actually take advantage of that in this now, so that'll be handy. And there's a lot of other fun things that we can do. So I think that's sort of the position that I want to take this. We'll see how well this works. I don't really know exactly where this is going to go. I don't know how this is going to turn out. I don't know what's going to happen. But we have to start somewhere. And this project needs to not be stuck. And the testing stuff kind of took everything off track. So we're gonna start somewhere else. And this seems like a good place to do that. And so I think I'm trying to think here. The hardest part, like the part that I spent the most time on with VR, or at least Asteroids VR, was the rotation, was making sure that you could actually rotate without getting like physically sick. And there's still some of that because that's just going to happen with what we're doing. But it's a lot better. And I think that's a solved problem. So I think the next thing is like destruction. Because that's really like the two main parts, right? There's can we move, and then there's can we blow things up? Because that's the components of asteroids. And so we have the move, or at least we know how we're going to do the move, but we don't know how we're going to do destruction. So if anybody has any ideas, throw them out, I guess. I've been thinking of a whole bunch of different thoughts. Everything from voxels to not voxels to just like generic prefabs that get smaller and smaller to just like single objects that all get blown up when you blow them up. I feel like voxels would be cool. It might be a lot of work though, and it might be something that we move to later, because I don't think we need that level of destruction right away. We can kind of do like an iterative approach and sort of have like blow things up and then ship that and then add voxels afterwards if that destruction is good. Spaghetti. Okay. I don't think that's going to work, but we can do, yeah, just different sorts of iterations on how destruction works and sort of build that up over time. And we don't need to constantly be changing things. Yeah. And so what I'm thinking, I guess I can sort of just show this. Whoa. Why is there a line connecting that? Oh, this is the... Okay, these are the lighting probes and things. Cool. So what I'm thinking is like we can do just as like a... Yeah, multiple chunks. That's sort of what I'm thinking. Where you can do something like this. And sort of... do this, and so that's like a bigger thing, and then when this explodes, each of the pieces kind of come out like that. And for testing we could even use just cubes and just keep making them smaller and smaller. And so that might just work. Let's actually, we're here, might as well, let's explore how that would work. So scripts, let's do destruction. This is just a test project, so this stuff probably won't show up later, but we can actually sort of play with this. So let's do a chunk. So I don't think we actually need to move all of them together. Like instead of doing what I had where we had 8 cubes, we can actually just have one bigger that's double the size in every direction, and then just shrink that by half, like every time it explodes. So if we just have I use chunk a lot, but it was thrown out, so we're gonna try that. So public int size, public int max or min size, and we'll just set this to like 8, and the minimum size is going to be 1. And so what this is going to do is every time it explodes, we're going to divide this by 2. So there'll be like 8 to 4 to 2 and then to 1. So this will actually be a fairly large thing, and then it will get reduced over 4 destruction cycles a lot. It should actually create quite a few extra chunks. 2 to the 3rd power? No. It'll create a lot. And so what we're going to do is do sort of a public bool destroyed equals false. Again, testing the script just to sort of see how this might work. So we have this destroyed thing. And so what we're going to do is just blow it up when this is true. So if destroyed equals, or if destroyed, let's create some additional explosions. So let's do a public game object chunk prefab. So that will be the prefab that we're going to use to actually create these things. Effectively, we're just going to be copying this object 8 times every time it explodes. Which I don't know if that's a great idea, but we're going to do it. So instantiate. The downside to this is we need to have the size of this, of all these objects. So let's create chunk at this transform.position plus this transform.local scale divided by 2. And now there is no create chunk. And let's actually call this create sub chunk. I thought that did something different. Create sub chunk. Minikube upgrade available. Did I just try to run this? Oh, let's not do that. All right, so create subchunk, blah. That's going to set this at the positive local scale divided by 2. So if this is a size of 8, it should do like 4. Stop. Don't hit F5. It's bad. This needs to create this at a new subchunk. So we're actually doing this. So let's do relative positions. Relative location, relative subchunk location. And so that way we can actually just do all the division and extra stuff here. And then we just need to calculate each of the 8 relative positions. So those should never change. So we can actually just use constants, sort of constants, because they'll change with scale. But here we have this relative subchunk location, which means we need to instantiate a new chunk prefab at this transformed position plus our local or relative subchunk location, and with this transform.rotation. This won't actually work with rotations because we're doing this relative position. Since we're translating it this way, things aren't going to actually come out exactly as we want them. We can use the matrix to make this work, but I'm not going to right now because that's not what we're doing. So we get our new game object out of this. Game object, or we'll call this the subchunk, equals that. Subchunk.get component. And we want to get the chunk out of this. Var chunk equals block chunk dot, and what we're going to do is set the size equal to this dot size divided by 2. And here we only want to create subchunks if the size, so if this dot size is greater than this dot min size. So if we end up getting too big, we don't want, or if we're too small, we don't want to keep creating more and more subchunks because then it will just go on forever. And eventually we're going to end up with these tiny little things, and that's not useful for anybody. And then finally destroy this dot game object. So it creates the subchunks and then destroys itself. And then set the size here. And then I think in the awake, this might work. This transform.local scale equals this, or yeah, equals this dot size times vector 3.1. And so that just creates a new vector with the size equal to the size. And so theoretically, this obviously doesn't do all of them, but it will do just one. So we should be able to recurse down individually one each for them. And hopefully that's enough to at least prove this point. And then we can add all 8 and just sort of see. This might be too much. So we might want some randomization of like certain chunks actually just disappear entirely. Maybe the ones that you actually blew up at. So like the way this game works is at least the default weapon is sort of bombs that you get to throw. And so you can throw them, it would stick into this, and maybe the subchunk that's closest to that explosion just continues to not exist. And so that would somewhat cut down on things. Cube. Let's make a prefab out of this. Sure, we'll stick it there. And then attach that to the prefab. Theoretically, I suppose we could use ourself as the reference for this. But there is the big chunk. If we click destroyed. Ooh. Its size is still 8. Oh, that's what's going on. One, we need to apply this. Open. And do sort of a recursive reference. There we go. I forgot the new Unity system for prefabs existed. Another advantage of going to 2019, we get all the fun new prefab stuff. So we do destroyed. It doesn't get any smaller because we're using awake. Ooh. And then it completely goes away. That's probably not right. Let's see here. One, we want this in the start because otherwise bad things are happening. And then start this and see what goes on. Scene, let's just move you over there. Because then we don't have to constantly be doing that. Destroyed? Oh, we are modifying our prefab. That's why everything's going horribly wrong. Destroyed. Click this and destroy it. Am I doing this right? This doesn't seem right. Destroyed. That position isn't right. Destroyed. Why does it go off into infinity? All right, so if we select this, it's not destroyed there. And then here, we destroy it. We get this new instance, which also isn't destroyed. It's not referencing the prefab, it's referencing itself. Well, that's why. So what's going to end up happening is we set this to destroyed, and then it creates references of itself recursively. And so they all have the destroyed flag set. Why is that happening? So this cube is referencing that cube, right? Oh, this is confusing. Let's see here. Test cube. What? Hold on. It is set to the prefab. But then why is it changing? That's super weird. Okay. I don't know how to fix that. That seems like a bug. Right? Open. This references the cube. Oh, references the prefab cube. Okay, I get it. We had two different conflicting things. So if I go back to my scene now, that is incorrect. Let's revert that. And we get our test cube. No, that's not right. Why is that referring to the test cube? It should be referring to this cube. Right? And then we go to scene, and it's still going back. Oh, I'm so confused. Cube references the cube. Is this some weird reference chain thing where it's deciding that it needs to reference itself instead of referencing the prefab? How do I make it reference the prefab? Ooh, I don't know if I like that. That doesn't seem good at all. Okay. Well, we can fix this, I guess, by hard coding our way around it. We can do that here. Chunk dot prefab equals this dot chunk prefab. If anybody knows how to fix that, let me know, because that doesn't seem like the behavior that you would ever want. Where it's figuring there's a this reference, and so it's changing that to always be this instead of the reference that you had pointed it to. So if you were trying to use a template, the template would shift because you'd be using It'd be referencing the objects that inherited the template. So I guess like recursive inheritance kind of breaks in this new prefab structure. Which is fine because this isn't how I would probably design this long term, but it's confusing and weird with the way this ended up coming out. Also, this isn't going to work because because we're referencing test cube, we would propagate that down, and test cube gets destroyed, so that doesn't actually exist. So we're going to set that to the cube, and then can I? There's no overrides, so you can't even apply this. It's just stuck. That's unfortunate. Okay, cool. We'll just move forward. Destroyed? It's moving too far, but that's fine. What? Game object has been destroyed, but we're still trying to access it. No. Why? What? Why is this happening? This makes no sense. Test cube is referencing test cube. Fine. What if we start the game and then replace the reference? You shouldn't need to do this, but I'm going to. Then we do that. We get no errors. It actually references the correct cube. Then we do it again. It goes too far again. Do that again. And then this one should destroy it completely. Yeah. Okay. So it does work. This new prefab system. I don't know what I think. It shouldn't be this hard to do that. And then just have that work. But it just doesn't. Because if I run this right now, that reference gets replaced. And I don't have any code doing that. My code is not replacing that reference to the prefab. It's just going away. And that shouldn't happen. And it is. I don't know. That's weird. Well, I guess since that doesn't work, we'll pretend like meh. Instead, we have this local scale. We actually want to do a fourth of the local scale, thinking about this a little bit more. And the reason for that is because we are dividing by 4. When we think of an object, if we have a dimension around it, if half of that dimension gets us all the way to the outer edge, and what we actually want is to spawn it in the middle of that. And so we want it half as wide, so it takes up half that space, but then we want it to be in the fourth so that it's adjacent to the ones next to it, because you get a fourth on either side. And so we actually want this to be a fourth. What I'm going to end up doing is do a var scale equals this. And then we're going to do a new vector 3 of scale.x, scale.y, and scale.z. We could probably write like a for loop or something for this, but it just seems easier to do sort of a matrix like this, which we can alternate like this. Let's not do that. We can alternate like this and do minus, 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 minus. Every other one of these will be subtracted. And then for the z, how does this work? This one needs to be inverted, and this one needs to be inverted, and then that and that. And so this sort of pattern should get all of our things covered, I'm hoping. And so when we actually destroy this now, It's a little clunky to destroy, but when we actually destroy this, what should happen, you can replace the cube there, and then click destroy. And we see no change, which is perfect, because we actually have 8 new cubes. And then I can destroy this one, and now we have 8 more, but these ones weren't destroyed. And then I can destroy this one, and we have 8 more still, and then destroy that one, and now we have a hole. We might actually want to, like I said, sort of apply a little bit more damage than this, because this is going to take forever to actually like get anywhere. But I think it's a good place to get started. And so maybe later this week, what we can do is sort of make this system and do it in a way that's a little bit more intuitive and easier to use. But for now, I think this is something you could play with. If this system worked and we had like locomotion and stuff and you could fly around, this would work. That would be enough to get a fully playable game. So I think that's probably where we should start. And the advantage of using cubes is, well, they're cubes, so they're relatively easy to work with. We can generate new cubes pretty easily. We can calculate what new ones should be. We don't have to worry about like complex cutting of meshes. While we're here, we might as well make this support rotation. So we have all of these new vectors. These are relative. And so what we need to do is translate them into world space. So var world position equals this transform dot position. So that's our current existing center point, and we have a relative position right here. What we want to do is get that into a position that is taking the rotation into effect. So we can do world position plus our this transform dot local to world matrix times our relative position. We may need to reverse these. I think there's an override for multiplication. No. Never mind. We actually may need to do a vector of 4. Dot multiply. Multiply vector. Cool. And so the way transforms work is they're just a matrix. We've talked about this in the past. There's a bunch of videos to what this is actually talking about. Maybe you could go check those out. We do some cool things with matrices and shaders and a few other things. But a transform is a matrix. And what that means is that there's a rotation, a scale, and a position all encoded into this. And that scale may be a problem. That scale may be useful. But the scale may be a problem. But what we're going to end up doing is multiplying this. And so we should get all of our things translated into the world space from the local space. So we have this local position of 0, 0, 0, forward, whatever. And has some orientation to the world. This should get a relative position into that world space rotation. Because there's a scale, it might not work as great as we want. But we can figure that out as well. So there's that multiplier vector. Cool. That adds that. Let's get this into here. So we put our world position in. And then, hopefully, if I'm doing my math correctly, which is often not the case, but if we do this and start, we can move our cube into this test cube. This is kind of an awful way to do this. And then we should be able to rotate this. So say we'll add some Y, some X, and some Z. Just to get all 3 of them in there. It shouldn't really matter. But if we destroy this, our new things should actually match that rotation. And they do, but like I said, the scale is a problem. So it busted them up and moved them way too far away because the actual position was multiplied by the scale. We should be able to fix that though. The easy way, I don't really want to say easy because that's a bad way, but we should be able to just divide out transform.local scale. Does that work? We can't divide two vector 3s. Why not? That seems like it should work. Well, what we can do, and this might actually be better, dot x so what I'm thinking is instead of having the scale be involved here at all, we can take that out and just do ones. Let's see here. We can write a regex for this. Scale dot x or y or z. What does the format look like? Oh, I need to turn on regex. That's not going to work. There. So that should match all of those. And we want to replace all of those with 1. And then we can do all the multiplication down here to do that. So when we expand this with our matrix, we can actually use this as a way to do that. And we can actually, to get the divided by 4, we can just do 0.0 or 0.25 f to get floats. And so if we do all of that, we need to fix the 2 that I did manually. We can take this scale value out. And then we just do relative subchunk location. And so that's going to be a relative position. Those vectors should get us 1/4 of the way in every direction relative to our point. And then the matrix should do the rest because it's already factoring in the scale. And so if I thought of that right, theoretically, it's solved all of our problems and made everything a lot more straightforward, I hope. And so we have this chunk here. We have our test cube. Let's subdivide. So destroy. And everything looks good. Let's pull this one out. So this is our one we're going to rotate. Let's rotate this. And do something like this. And if we destroy that, now we have all of these and they're being put at the correct position and everything just looks normal. Like it didn't actually get destroyed until they start moving apart and all that other fun stuff happens. So there we go. I think we can use this as our destruction thing. And then everything can just kind of move apart. And this sort of, I guess, gives you a fun way to move as well. We could go even more advanced and actually like have some sort of mechanism to actually hold things to one another. So when this is destroyed, for example, even though there's these 8 parts, we could keep most of them connected to one another, like have some sort of connection weight that holds all of these together until an additional force is applied, and then they would break apart. But for now, I think we'll just do subdivisions of cubes, and that should be plenty to get this working. But it seems to just keep working, so that's handy. But yeah, I'm pretty happy with this solution. We'll do more of this, I think, in the next week or so, and hopefully get this to a point where we can actually like ship it and it actually works. And then once that's done, like the visualization I have for this whole solution is sort of a ring of asteroids around a planet. That's just sort of like this thing that I've wanted to do forever, and just have sort of an infinite loop of constantly randomly generated new things, and then the gameplay just sort of works in that loop. So there's always new stuff, and it just looks realistic, and you can sort of interact with that. And then we can expand on it from there. But that's sort of like an infinite mode that I've been thinking of, and that's sort of the first thing that I want to ship. And so once we get to that point, I think this will be something to like a playable state where you can actually download it. That's probably a while away, at least a month or so. But we've already done a lot of this before. So like the locomotion and stuff, we kind of know how that works. We just need to actually code it. And coding it isn't that tough. We just need to make sure that it feels right. So hopefully this is sort of stuff that we can kind of knock out pretty quick. But if it's something that I think will take longer, we'll probably do live streams for this. But otherwise, we can just do normal videos and hopefully get a pretty good cadence of those coming out. So there's new fun stuff coming out. But yeah, I think that's it. I'll leave it here. It's pretty late. We've been going for 2.5 hours. I started this pretty late. People will have to let me know when a good time for streams is. There's a lot of people from Europe and stuff who watch the channel, and this time is awful for them because this is like 5 a.m. or something for them, and so not great. But there's not really ever a good time that works for everybody because that's how a globe works. And so we just need to figure out what's the best solution. And yeah, you'll have to let me know if there's any questions. I can answer those, or any like feedback or anything. But this is sort of as far as I wanted to get. This sort of covers a lot of like the experimentation stuff that I was hoping to get through, and so we should be. I think we're in a pretty good spot here. I'm feeling good about this. Not so good about the testing stuff. I still don't really know how that works. Like, maybe I can just tests. Create edit mode test assembly. Sure, tests.tests. And let's create a test script. Test, just test. Chunk test. That actually, there we go. But if I try to reference my, wait, does it work now? No way. Okay. Well, chunk, wow, chunk dot destroyed equals false. Let's do like the most basic test. Assert r equal chunk and null. We need to assign that, set it to null. So this didn't used to work. When we were trying to do testing earlier, this didn't work. It would throw a whole bunch of errors that it couldn't find chunk. But if it does work, all right, we're still getting in the same error. The typer namespace chunk could not be found, which means everything is still, unfortunately, broken. Unless there's a way to add these assemblies. and I do not see them. These look like a bunch of normal Unity things. Test assemblies. Will net references assembly will be used for tests, blah. Yeah. So we're still in the same issue of we can't reference our types. And if I fix that, then everything becomes unreferenceable. So we'll come back to testing, I guess, or write our own or do something else. I just hit that again. Don't do that. But that's sort of where that is. And that was sort of the problem that we hit, was testing didn't seem complete. Like it's shipped and it's there, but it doesn't seem to do what I want it to do, or maybe I'm just not understanding it. But whatever the solution or the problem is, where we are, it just didn't solve the problem. So we will ignore that and move forward with doing stuff manually, I guess, for now. And we will maybe figure that out as time goes on. But for now, I'm going to leave it here and wrap up the stream. But hopefully there will be more of these. And I'll try to do them more in like a more Europe-friendly time. I'm on the west coast of the US, so that is actually a little bit hard. But yeah, we'll see. Yeah, I don't know when there will be another one, but I have some really fun videos planned for this week. So those should come out soon. Other things, yeah, I think that's it. But I'll leave it here, and then we can pick this up in the actual project and do all this fun stuff. But I don't see any other questions. Thanks for stopping by, hanging out, and watching me poke at Unity and experiment with VR. I think we'll have a lot of fun with this project. There is another project that I'm hoping to start as well, that I would appreciate some help with as that goes on. I'll share more about that after we start it. But that's another bigger project. I kind of want to start doing those because they involve a little bit more than just like these tinkering projects like we did with the visualization stuff. These are not the visualization things, but we had that visualization project. A lot of those are like exploring specific things. I want to kind of dive into like the deeper nitty-gritty things of what happens when you actually try to like use that kind of stuff, and that isn't always super easy in those quick examples. And so some of the choices I make and things, I want to come up with a better way to show why those choices are being made, and hopefully some of the new stuff I'm working on will show that. But yeah, that's it, and I will see you in the next video. Hopefully tomorrow. Well, in probably 20-ish hours. We'll see. So, till then, see ya.